Alright, you guys, the next application of radian measure is this idea of the area, and I forgot to use the word sector. So let's first get a picture of what in the world I'm talking about. Right? So we have a circle. The circle has some radius, and what we're going to do is sweep out a central angle, right, by going along the edge so many radius lengths along the edge. Okay, and when I'm done, I've stopped there. We have, again, we know that the arc length is r times theta, and so what I have, and let me highlight it in red, is I've just created, right, that with that circle combined with the swept out angle, is I've just created a piece of pie, if you would, and that is what we call a sector. So what we're going to try to find is what is the area of that sector going to be, and it turns out that the way we're going to, there's a lot of different ways we can prove this formula to us, to ourselves, but what I'm going to do is use the idea of a percent. And so what we can basically see is that the sector, right, is some percentage of the total area, okay, of the circle. And we'll talk about that percent in a moment. So the area that we're looking at, right, that chunk, that piece of pie, is actually some part of, or a percent of, the total area. Now that's good news for us because we actually know what the total area is, right? So the area of the sector that I'm looking for, right, is equal to some percentage of, and we know that this is pi r squared. So that would be our measurement, all right, of the area of the circle. So all we really need to do now is find out what is that percentage, okay? And to help us out with that percentage, what I'm now going to do, right, is use the arc length, right, and the circumference. Okay, so the circumference for a full circle, we also know to be equal to 2 pi r. Okay, so that would be our circumference of a circle. And we know that the arc length, right, so this would be, the circumference is the walk all the way around, and the arc length is going to be r times that central angle. Okay, so if you guys are following me along here. And the percentage I'm looking for, right, we always put the total down on the bottom, so that would be my total circumference divided into the arc length that I have. That's classically how we set up a percent. So the percent of the arc length to the circumference should also be the same percentage because of the proportionality, right, between the sector and the total area. And so we throwing things in, the arc length is r theta and the circumference is 2 pi r. Doing a quick division with the r's, we get that this percentage is theta over 2 pi. So there is our percent. So now I'm going to go back up to here, make that substitution, and our area of our sector, right, is the percent theta over 2 pi times pi over r squared. And if we simplify this, the pi's will cancel out, rearrange it, right, we have 1 over 2 r squared times theta. And that is our area of a sector. So I need to know two things in order to find that area of that sector. I need to know the radius of the circle, and I need to know the central angle. And again, because of the setup we did, it's imperative that that central angle is in fact measured in radians. If I measured in radians, there is how much pi, right, I'm going to eat if I know my central angle and I know my radius. So there's your build up for the formula. Now what we're going to do is get a chance to use it and push some fractions around and practice those skills. I will see you guys in the next video.